Hello, and we are back. We are finding x-intercepts and solving quadratics using Poh-Shen Loh's technique that he published in late 2019. So we have this basic quadratic function, f of x equals x squared minus 6x plus 5. I've graphed it over here. Of course, you're not going to necessarily have that graph, but I just wanted to show you what it looks like. We can see what these x-intercepts are. We know that it's going to be 5, 0, and 1, 0 because we have that. But if we didn't have that, and if this was more complicated, this technique will work for any function, whether or not it's factorable, which is really cool. The first idea is to remember that if, assuming that a equals 1, if a doesn't equal 1, we need to divide by what a is, the coefficient in front of the x squared. If a equals 1, then we have this coefficient of the linear term, negative x. And we remember that the axis of symmetry is the negative version of whatever that number is over 2. So in this case, it's positive 3. So the axis of symmetry is x equals negative 3. So I'm going to just draw that right here. We can see that that is an axis of symmetry. That is the middle of this parabola, and each side of it is a mirror of the other, okay? And the key point for this is that we know that this that the two x-intercepts are equidistant from the axis of symmetry. There's some distance here, right? And so we're going to call this distance d, right, from the axis of symmetry up to the x-intercept there, or down to this other x-intercept here, okay? So if we were to factor this, right, we want to think about what numbers multiply to 5, right, and add to negative 6, okay? So considering that we have two things that are multiplying to 5, but then add to negative 6, we can think of it as a difference of two squares. This is the new part, all right? So it's this axis of symmetry number, and it's going to be minus that d or plus that d. And those two things are going to multiply to 5, okay? And they have to add to negative 6. And it makes sense that they're going to add to negative 6. If you think about it, 3 minus d plus 3 plus d, the d's cancel, and that's going to add to 6. But the nice thing about setting it up this way is if we multiply this out using, it's just difference of two squares, right? So it's 9 minus d squared equals 5. And we just solve for d there. You can do it a few different ways, right? D squared is 4, square root both sides, and I have d equals 2. D also equals negative 2, which would work to get the same answers. With this technique, you actually can disregard the negative version. So we found that distance is d. And so now to find the two x-intercepts, we just need to plug that back in. So it's going to be 3 minus 2 is the first one, which is 1, and 3 plus 2, which is 5. So we know those two x-intercepts are 1 and 5. And if we wanted to write it in factored form, right, we know that the x-intercepts are those two things. So we would just write x minus 1 and x minus 5. Okay. Now, the nice thing about this technique is that even if it wasn't factorable, we could do this exact same thing, and it would be just about as easy, and we would get the irrational roots. Okay, so I hope that clarifies for you, and I appreciate your time, and we will see you next time. Take care.